So FononTech is actually a startup from TNO Hall Center. So we're actually setting up in this coming month. And with FononTech, we're going to reshape 3D microelectronics. FononTech, so phonon is Dutch for, phonon particle, so it's a heat particle. And we're using this heat to reshape the microelectronics. So if you look at the current bulky electronics on the left, we want to integrate electronics more and more into our lives. So in the end, we want to go to fully integrated. You don't even notice these electronics anymore. So the market drivers are a smaller form factor, increased performance, and more functionality. So this is pushing the manufacturing to go from traditional packages, such as this QFN package, to miniaturize all these electronics to advanced packaging. So you package not only one chip in one big package, but you package multiple chips into a small 3D space. So this is the big problem, right? So on the left side, you see the traditional chip package, QFN package. You see the wire bonding technology. It's 2.5D single chip integration. Large contact pads because it's limited by the bond pads, by the wire bonding, and this gives you a low performance per volume. So you see in this box there's still a lot of room to improve. So we want to go to advanced packaging, so not having one chip in one package but have multiple chips. For example, 5 chips in one package. So this has to be connected all in 3 dimensions. So the problem is you need to go to smaller interconnects, right? Smaller bond pads, you need to interconnect that, and then you get high performance per volume. So the big problem is you need to first go to very small features, right? That's difficult. Then you need to do complex 3D interconnects. So you need to that combination is very difficult, and there are solutions for that already. But the biggest problem is that it needs to be scalable. You need to go to high volume manufacturing. And there is no solution at the moment to do this. So this is where impulse printing comes in. So impulse printing is a brand new technology which we launched a couple of months ago. And the basic principle is pretty simple. What we have is a impulse printing plate, and it has a very rapid heating surface. You can compare it to a light bulb, but then 1,000,000 times more powerful. So it rapidly heats the surface, and when you put any liquid on top of that surface, it will evaporate a very little fraction of that liquid. And that liquid can be basically any ink. And when you evaporate this liquid, you create very small bubbles, you create pressure, and that pressure shoots the whole pattern to the acceptor substrate in a non-contact manner. So then you can use basically any substrate, any 3D surface. This is an example of how it works. So we're also showing it at our booth. So you smear these grooves full of ink, then you rapidly heat, and the whole pattern transfers. So it's all parallel processing. So with this technology, you can do micron-sized features because we make this plate with a lithographic process. So these grooves can be 2 micron in size. We can do complex 3D interconnects because we transfer this whole pattern. It flies at around 10 meters per second, and we can use the momentum of the ink to conform to go over steps or to wrap around surfaces. And we can do high volume manufacturing because of this parallel processing. So if you look at the whole additive manufacturing industry, there are contact printing and non-contact printing. And basically what we do with impulse printing is we can take the high volume manufacturing on 2D substrates, so like screen printing, stencil printing, gravure. We can take that concept and we can transfer it to the non-contact printing technologies, but then all at high volume manufacturing. So here's an example. So here you have a chip. So we could, for example, print the die attach for the chip. You can print the solder paste, but here's the problem, right? You have the small contacts on the top of the chip, and then you have the larger contacts on the lead frame. So you need to print, for example, first a